Yevgen, it's all yours.
Thank you, Evgeny. Yeah, hola Barcelona, welcome to this last talk before the lunch break. So who is already tired and wants to eat? Please clap your hands. Oh, okay. I actually didn't expect it, so I will try to entertain you as much as I could to bring the food as much as fast to you. So before we start, I have to reveal one secret. Please don't tell it to anyone. This is my very first conference talk on a big stage. So I'm very thankful for your patience. And as a gift, I will try to not speak longer than 40 minutes so that you are released a little bit earlier. So who was there yesterday during Abraham's talk, where he presented his small red steel as a last beacon of hope of human agency? I would like today to build up on this steel and address your anxiety if you have some, because AI brings a lot of change, and a lot of people are anxious about it, anxious about maybe job loss, anxious about change in general, like leaving comfort zone, or maybe anxious about singularity. So I will try to address this anxiety and maybe make you feeling even more anxious. Let's see. I will introduce myself. I was born in Kharkiv, Ukraine. Now I live in a small city, Bruchsal, in southern Germany. I'm trying to build an IT community there by organizing IT meetups and hackathons. By the way, I'm systems architect. My customers were from railway sector, from transports and logistics, from medical devices, and last but not least, maritime navigation. I'm an author of a framework that I call socio-technical engineering, a systems engineering for socio-technical systems. Basically, the idea of it is to try to take classical systems engineering we already know about and to reinterpret it in the domain of socio-technical systems. But today, I will not talk about this. I will try to answer one single question. How will AI reshape software engineering? So basically, it's what Jackie said yesterday. Jackie is not here today. That any innovation is not additive. It will not be software engineering plus AI. It will be completely new software engineering. And my goal is to look into the future and try to understand how it will look like. Unfortunately, I hasn't been in the future yet, so I can only guess how it will look like. Basically, every time I get into the future, it becomes past. So the future is very mean to us. That's why the only thing we can do is make reasonable projection. And when facing a new technology like AI, we usually try to use it within common known categories. For example, as we see in smartphone, we categorize this as just a smarter phone. So we used a known category. The same we do for, sorry, there is something with the slide. The same we do for software engineering. We have coding, we have requirements engineering, we have operations, software architecture, UI, UX design, quality assurance, and many other categories. So last week I was in Berlin, and at requirements engineering conference, there were at least 3 talks about using AI for generating user stories and requirements. This is an architecture conference. We had yesterday talks from Jackie about using AI for generating diagrams. There was a talk by Abraham about embedding UI into the decision-taking architecture process and so on. So basically now in every of these categories, there are plenty of conferences where people look how to apply AI within these categories. But as the new technology evolves, it reshapes its environment. So we started to use smartphones as smarter phones, but now they are rather pocket PCs. So if we would know it from the beginning, we would rather call them computers and not smartphones. And the same will probably happen with AI. The question is how? And to answer this question, we need to understand one dictator's role. So every dictator learns this rule in a kindergarten for dictators. And the rule is, if you want to write the future, you have to rewrite the past. So basically, every dictator, the first thing they do, they just rewrite history books. And if you want to write the future, or to read it at least, we have to rewrite the past so that we can connect it to the future. And this is what I will try to do today. I will tell you a story of software engineering, not as a story of innovation or success or anything. I will tell the story as a story of survival under severe conditions. And I will make a point that AI will remove these severe conditions, and we will wake up in a free world of software engineering. So what this story is about. Any complex system, like software engineering, is shaped under constraints. For example, a snowflake is shaped under humidity and temperature, cities are shaped under space and infrastructure constraints, and solar systems are shaped under gravity and centrifugal forces, right? And it's not hard to see that once we relax those constraints, or once we introduce new constraints, that the systems also being transformed. The same will happen also for software engineering. Here's just one example. Let's take a constraint of short food storage period, like for the meat. In the past, we had farming everywhere. And since we couldn't store food for long, we had to live close to the farmers. We would buy food in smaller stores. We would connect with the farmers. We would bring the food home, cook it immediately, and eat it immediately, synchronously with our relatives, right? Because we just can't store the food. We have to deploy it immediately in production. But now let's look at this guy in the corner, the fridge. So fridge relaxed this constraint. So what we have now, how does the architecture of our society look like? We have farming, where rare, but really large scale. We live in large cities, far away from farmers. We buy food maybe once a week. We bring it home, put in the fridge, cook later, eat later, often eating alone. And when totally asynchronous, we don't connect with a farmer, we don't connect with a store seller, and so on. So we can see the fridge as a transfer function that makes us fed but lonely. So, so now the question, which are the constraints that shape software engineering? I think there are two of them. The first one is that we humans have limited cognitive capacities. So limited doesn't mean small, it just means limited. And another one is that human work takes effort and time. And my point is that the way we do software today can be related to these two constraints. So let's see a couple of examples. So first is that human brains have limited cognitive capacity, which means that we have to distribute cognitive load. If you look at this nice guy 80 years ago, if he would have a LinkedIn account, he would probably write, "I'm an engineer," right? Because it is what he was back then. If he would work today, he would be software engineer, hardware engineer, business analyst, Scrum Master, product owner, even PMO. Because it is what he did back then, which means that our first action to react to these cognitive capacities, limited cognitive capacities, is to introduce categories. Okay, this slide is broken again. So we broke this engineering into subcategories like coding, operations, and so on. And if we look at the socio-technical architecture, how we do work today, we will see that we have different people in different roles. For example, there is developer writing code, there is a product owner working with Jira, somewhere there is a UX designer working with Figma, there are business analysts working with Confluence and some managers working with PowerPoint. And there is links between people because people have to align. But why do we have to align? It is not an end goal. Actually, what we want is to align artifacts we create. So this is the single reason, basically, why we have all this meeting stuff, Teams, channels, mails, and so on. We just want to assure that the artifacts we create are somehow coherent, right? So we invented 2 tactics to address this problem. The first tactic is to enable breadth of one single head by reducing the depth of the cognitive load required for doing some work. Because if we don't have to deal with details, we can look broader, and hopefully, if the information is one single head, then it should be aligned, assuming we don't have Alzheimer's syndrome or so. And another set of tactics is increasing alignment between people working among different categories on different artifacts. So let's see what we created as a result of following these 2 tactics. So enabling breadth means the first innovation was to create high-level programming languages. Because if you don't need details about the structure of machine, how it works, we can focus on implementing business logic. So this is the first native step. Another great step was an invention of object-oriented programming, because by encapsulating complex structures within classes, we could allow ourselves either to think on the class level, so in the breadth, or being within a class and thinking in the depths. But we had never to work in kind of rectangle, having to deal with the breadth and depth simultaneously. So, what we invented to increase social coherence? I think there are 2 major innovations over the last 80 years. The first one is teams. So teams are basically creating virtual boundary to facilitate communication and basically create some coherence and alignment between people who are in the team. And another innovation, I think, was at DevOps, because DevOps aligns people around common tasks, common responsibilities. We also had socio-technical tools of creating coherence, for example, domain-driven design, which kind of provides ubiquitous language and communication patterns to talk about common things with common terms. Or collaborative modeling, where we co-create models synchronously with the hope that we align while doing so. Now the heavy artillery, model-based systems engineering. I think we reached yesterday more or less consensus that we should unite around hating Visio. But no one says that no one mentioned enterprise architect software. It looks like it doesn't deserve our hate. I think it does. But it is actually a helpful tool. Because what is the entire idea of model-based systems engineering? You kind of put all artifacts you create in one single system, all architecture diagrams, requirements, and so on, and you connect them. So by doing this traceability, manually, of course, you establish kind of alignment between the artifacts with the hope that you keep them aligned over time. Another invention was the application lifecycle management tools like Polarion. I'm not sure if it's known here in Spain. So this is kind of Jira, made in Germany, quadratisch praktisch gut. It also tries to put requirements and working items in one system, even documentation, architecture documentation in one single system, and link it together. But again, these links are still established by us humans. So we also had a lot of org design innovations like Team Topologies, org topologies, Agile framework, Unfix. So these are the tools to create alignment and coherence between people and artifacts they create. And these are, in my point of view, answers to this constraint that we people have limited cognitive capacities. So let's look at another constraint, which is that we people have When we work, it needs effort and time. That means that we have to avoid costly changes. And I think our greatest invention to address this issue was the invention of software architecture. Because, okay, it depends on what the software architecture is. We have, I don't know, 300-400 architects here and maybe 800 definitions of software architecture. The one definition I particularly like, because I wrote it, is that software architecture is a navigation of complexity in socio-technical systems. This definition addresses a lot of aspects. So first of all, it is a navigation. It is what Neil told yesterday. Architecture is not about making decision, but about continuously making trade-off decisions over time. This is navigation. It also says it is in socio-technical systems, not only technical systems, because socio-technical systems have also business aspects, they have operational aspects, they have political aspects, and by the way, also technological ones. And it is about complexity, because complexity is a source of uncertainty, uncertainty is a source of change, and we humans need time to react on change. That's why we need software architecture. It is also what Gregor Hoppe said, that architects live in the first derivative, while derivative being the pace of change. So we architects are the guardians of change. And our most common tool to react to change, is try to encapsulate everything. Because we know that shit happens, but it shouldn't hit the fan. So we try to encapsulate it. Because we need time to do our work. And the driver of encapsulation is for sure an abstraction. But what we shouldn't forget is that abstraction has a price, right? If, for example, we have dogs and cats, and dogs make woof woof, cats make meow meow, and we want to homogenize them behind one common interface, then we would dehumanize them. In that case, they animalize them behind one abstract interface being called speak. So abstractions always have price. And we had a lot of abstractions, like all possible books on patterns propose a lot of decisions which are basically built upon abstractions to achieve certain level of encapsulations. It's not only this book. For example, anti-corruption layer is also an idea based on encapsulating something. We have also technological innovations to encapsulate changes. For example, containers or virtual machines encapsulate variability of the physical nodes where we run software. Serverless basically encapsulates the variability of configuration, and Java virtual machine, for instance, encapsulates the operating system. And so this is the end of this story, where I wanted to point that we invented a lot of things, technological, social ones, but these were basically more or less scaffoldings for us humans for being able to build houses. And my point is, if these houses were being built by drones, for example, we would not need these scaffoldings, or at least we will not have such a big need for it. So let's look how AI, whether it shares our constraints or not. So AI doesn't need a vacation. It can work 24/7. It can multitask. When it does work, it does it really fast. And it doesn't have any limited capacities for cognitive load. It just cries for more and more data. So what could happen next, given that the AI doesn't share our constraints? We will for sure start, or we already started, co-creating artifacts. This is the first stage, where we people together with AI work on the same mediums to create artifacts with a target to compiler. As Abraham told today, we have at least two stakeholders: artifacts for people, artifacts for compiler or machines, and the third stakeholder which will be introduced is AI. So basically, we share the same sheet, we share the same language for different stakeholders, which is kind of weird as a business process. And if you look at the overall socio-technical architecture of software engineering today, we will find different people in different roles working on artifacts together with their co-pilots. What will for sure happen someday is a migration from co-pilot to pilot. So in this case, we will not create artifacts for humans anymore, or maybe less so. Now AI can create artifacts on their own, we just talk to it. So what will happen next? I think AI will start disrupting abstractions, because abstractions have price, and AI doesn't want to pay this price. For example, if Java promises write once, run everywhere, AI is not interested. AI just says, okay, tell me once, I will deploy it everywhere. I will generate code, native code for everything you wish. We don't need these human-made abstractions, okay, in long term. We will for sure, or I suppose so, return partially to machine languages, because AI doesn't have to create some abstract high-level code. It just can go back to the roots and create the code for the machine, so it will kind of eat compilers. And I think AI is decision agnostic. It doesn't have to think things up front as we architects do. For example, while creating a system, it could say, well, let me just start with a monolith and a document database. It will create it in a minute, deploy it within a minute in production, and then see in production, oh, no. I will be better off if I would have here a relation database and a couple of subcomponents. So it will shut down the system, regenerate it within minutes, and redeploy it again. So AI is not afraid of change. It welcomes shit. Because it can deal with it. It can redesign and redeploy any system within minutes in the future. What might also happen is presented here. So if you look at the classical three-tier architecture, we have front end, usually very thin, and we have a back end with the major part of the business logic allocated on the back end side. Not because it is better to do so, but partially because it is more convenient for us humans. If we will put some business logic in the front end, then we will have a lot of coupling between the front and back end. It will be harder to maintain the code in front end and back end and create it for different front ends. So we try to put as much as possible in the back end. But why? There is no reason if the AI can just generate everything. And I think we have kind of 500 people here. Everyone has a smartphone. And what does your smartphone is doing now? I think nothing. So Apple and Samsung brag every year that they created even faster processors. But these processors are not loaded right now. And this is a shame, because we put a lot of calculations in the cloud where we have to pay to the cloud vendors. Well, we have so many computational power in our pockets. And I suppose that in the future, AI will reuse this computational power in our pockets and deploy more business logic into the front ends, web browsers, smartphones, and so on. Not everything for sure, but there will be a part of it that could be migrated. So at the end, we will get this picture where everyone is working with AIs on creation of the artifacts, fully supported by pilots. If you look at this picture a little bit longer, we can see that we can basically invert it with humans on the outside and artifacts and AI in the middle. And what might happen next is the emergence of new connections, because now with all artifacts in the middle, AI can start establishing connection with each other to align those documents, those artifacts. Because our end goal was at the end to align on artifacts, not to align with each other. Which automatically means that maybe our connections between humans will be less relevant. They will not for sure disappear, but they will be at least relevant because AI can take over a part of alignment work for us. And if we project this one step further, I suppose we will end up having some knowledge-based system in the middle with all artifacts like code, diagrams, requirements, UX, UI designs. So basically everything what humans create today being put into a connected knowledge-based system, fully administered and maintained and kept aligned by the AI. And this is the point where I think AI can turn from the tool to an agent while initiating discussions with humans and saying, oh, by the way, you have one requirement. I'm not sure how to address it in the architecture. Let's discuss it quickly. And we humans in this picture, we are just periphery devices, input devices to bring data into the system. Because AI can't sense the environmental data as we humans do yet. So we still have the power of being a periphery device. So, and if AI can align artifacts, then will we need tools of human-made alignment, like meetings, managers, or teams? I think we will have still some sort of it, but for sure not in a way we have it today, because a part of this work will be redeployed to AI. So let me conclude briefly. AI is less affected by human constraints than humans do, and as a result, it will reduce the need for human-made alignment, for human-made scaffoldings of creating software. So there will be some closet with human-made innovations around encapsulation and human-driven alignment, like teams, managers, and so on, where we will be able to put lots of innovations we created so far, or at least challenge them and rethink why we are using them. And by blending the artifacts we create today from different categories, AI will be able to reshape software engineering as we know it today. But again, this is just an assumption. I haven't been to the future yet. It is just how it might look like in the future. Just to give you a little bit outlook what could happen next. You know, maybe some of you are familiar with this meme that developers are not... It's not mine, it is old one. So we can't worry about AI because it doesn't know what we want. Yeah? I think this meme is very arrogant, because this idea that we humans as a singular source of free will is kind of a new idea. If you look back to Fernando's presentation where he shows the human's history in many pages, now this idea of an individualism where each lives matter, it is a radical one. It would be just in the last page. Every time before, it wasn't like, oh, this is a human being, it's allowed to have free will. So this is actually something new. And AI in the future could represent other sources of free will other than humans. We started already now asking AI what do we want. It is the first shift in this power transition. But AI can also represent animals, it can represent the planet, whatever it is, it could represent nations. So if we look at this, back at this diagram, where humans are the sources of real world data and will, so via ingest requirements into the system. In the future, it might change as well, because AI can start generating use cases on their own. And we people will maybe end up being production environment for UI. And I suppose it will be even a big privilege to be a production environment and not a testing environment. So thank you very much. We still have a lot of time.
Thank you, Yevgen. What an inspirational talk. So we have many people just praising you for an awesome talk, for an awesome presentation that you made. But we do indeed have a couple of questions. What do you think will be the data sources that will enable that futuristic picture with AI in the center? Because data is still the input.
Data is what?
Is still the input.
Okay. So I think the question is not what the data sources are, but how to integrate them in one system. Because today we have code and Git, UX designs in Figma, and the first one who will integrate everything in one system will enable those capabilities of AI. I suppose Microsoft will be the first one because they already have Azure DevOps and Microsoft 365, so they are the first one who have lots of things in one place. I also suppose we discussed it in the speaker's corner that AWS will try to buy Atlassian, yeah. Because if they don't do it, I suppose they will lose the race. Yeah.
Good. A clarification question. Are you referring to LLMs or AI in general, including future approaches? Do you think LLMs will be capable of delivering all you've envisioned?
Oh, I just meant AI in general, whatever it is, implementation details.
Will our roles as software architects and engineers be to write business requirements as tests for our AI overlords?
Oh, say again. Okay, I don't know. Maybe in certain stage, yes. I suppose we will kind of shift left towards being more on the requirements side and less on the design and testing side. And basically, we will be more product owners, I suppose, for a certain time.
We have a question about the safety of application. How do you think AI and blending of software engineering roles will affect the safety of applications?
Well, it depends on the definition of safety and the definition of the user. So who shouldn't be harmed? If these are us humans, I'm sure we can also train the AI to build in safety, because today the safety is guaranteed by us humans. Humans have humans error. So the history of safety is written by the blood of human beings.
If software architecture is navigation across complexity in socio-technical systems, how will you define the goal of an architect?
To prevent shit from hitting the fan.
And I would say the last question would be, put on the edge, why do we even need a knowledge-based system? Can we just need documentation in a form that AI can read it?
Okay, I think it would only work if we just need a general language to describe all our artifacts, from code to user stories to requirements. And I don't think that we will get there.
At least soon. Thank you, Yevgen. It was a great talk.